Hey guys, I'm just going to kind of talk through section 6 and 7. This is the same kind of information that was in the Ed puzzle. I just thought maybe we would jot down some of those key ideas on our notes. And there was a couple ideas that he didn't talk about that I wanted to talk about. So 34.6 says the damaging effects of electric shock are the result of current passing through the body. So I get this question a lot. There's birds up on a power line. How come they don't get electrocuted, right? If I touch an electric, if there's a there's a storm and an electric power line's touching the ground and I touch it, I'm going to get electrocuted. Why doesn't the bird get electrocuted? And so we're going to try to figure out why there's no current passing through the bird. But first, here's something to think about. So resistance, remember, is how much the material is slowing down the current of electrons flowing through it. And so it depends on a lot of things. Okay, so if you're soaked with salt water, your body has 100 ohms of resistance, which is not very much, right? Electricity is going to flow through you, no problem. Okay, if you are very, very, very dry, and your skin is cracked and you've been out in the desert, you're going to have 500,000 ohms of resistance. So, two people could touch the same kind of a voltage source, and one of them, if they're really dry, would probably be okay, whereas if the other one's wet, they're going to have a ton of current flowing through them. Remember, the higher number of ohms, that's the resistance, would go with less current. And obviously we know, don't blow your hair dryer in the bathtub. That'd be kind of silly. But let's think about our bird. Okay, so here's the power line up in the air. Yeah, boy. Here's my bird. Oh, he looks pretty good, actually. I'm pretty happy with that bird. Till I get to his feet. No, okay, so here's his 2 feet. Okay, so in this power line, it's alternating current. So there's electrons going one way and then electrons going the other way. They're going back and forth. But is there a difference in potential energy of the electrons here versus here? Is there a potential difference? Okay, no. Okay, they can just flow through the wire, no problem. There's no difference. So between where his foot is here and where his foot is here, there's no potential difference. Remember, you only have a potential difference if you have something that is, resisting that flow. Or, remember, if there's a difference. So now, say that power line, there's a storm and there's that power line, and now it's touching the ground, and here comes along me, and I reach out and grab it. Now, is there potential difference between here and the ground where my feet are? And the answer is absolutely yes. So electricity is quickly going to flow through me to get to the ground where there's a lower potential energy for those electrons. So the reason is that wire is suspended and it's not touching anything that it can flow to, really. Okay, and it could be flowing through the bird, but it's not going to really hurt it because there's no potential difference to make it go in a really dangerous way. All right, so then the big idea here, AC and DC, AC, whatever. So we have DC electricity, which is direct current. He talked about it always flows in one direction. Anytime that you have anything powered with a battery, we're talking about direct current, right? The electrons are always flowing away from the negative charge of the battery and towards the positive end of the battery, and it's a one-way ticket, right? And when the chemical reaction in the battery is done and it's not producing negative charge anymore, there's nothing to drive the electrons and it's just done. Okay, so direct is anything that you are using a battery for power. Alternating current, on the other hand, as the name suggests, alternates. It goes back and forth really, really quickly. And in the United States, we went with 120 volts. I don't fully know why, because power transmission is better and more efficient and loses less power over long distances the higher the voltage. So Europe uses 220, but this is what's in your house, since we all live in America. And the frequency, how quickly the direction of current goes back and forth, is 60 hertz. Okay, so this is one of those. I might have to try to find a video of this, because my physics professor had this really cool thing. He had a light bulb that was one color when the circuit was going one way, and it turned a different color when it was the other way. And you couldn't see it. It looked like it was just one color when you were looking at it, but then he would spin it on the end of a string, and you could see the two different colors. So I might try to find a video, something like that. But to give you an idea how fast 60 hertz is, it's really fast. But the purpose of both of these types of power is to give a voltage, give a potential difference, something to push electrons through and get a current going. I'm not going to ask you to do anything besides that Ed puzzle for a grade, but tomorrow we'll start talking about power a little bit, and that's a little bit more math intensive again, so you can look forward to that. Talk to you later.